Okay, I think we are live. Wait, let me just. Okay. Yep. Okay. Uh, Problems there. Okay. Problem is available in the. You can check the video description if anyone wants to join reading the problems. But yeah, basically we are going to talk about EGI 2025, which just finished, and this is basically the leaderboard. So yeah, congratulations for the winners. Um, there might still be appeals, like contest just ended like 15 minutes ago, so I can imagine like the scoreboard might still change due to appeals or anything, but like this should be pretty much the result. Yeah, congratulations to Paulina from Poland for winning this year's EGI. And yeah, so I'm going to read the problems for the first time. We have Long share with me. Say hello.
Hello, hello.
Um, okay, yeah. Um, the sound okay? Longs? Can you hear me? Oh, I see. Wait. Wait a sec.
Yeah, but I think like your sound is doubled.
Do you
Not sure
watch
how to
the
fix it.
stream maybe? Is it because you're watching the live stream? No?
Give me a... Yes.
Ah, yeah, that's why. Okay. Is it good now? Technical issue.
Okay, try. Uh, we got now. Hopefully.
Okay. Yeah. Don't listen to live stream. Live stream has delay. Um yeah, okay, so we're going to talk about the problems. When we have a chat, is Sublime free for CP? I guess like you can just download Sublime, right? It's the unlicensed version. You can just use the unlicensed version. Okay, yeah, let's talk about the problems. So yeah, let's open the first problem. And contrary to the first day, the first competition day, I haven't read the problems yet. So this is going to be the first time for me to read the problems as well. Okay, the string problem. Klungs, if you've managed to understand the problem first, feel free to explain the problems.
There's no.
Okay.
Yeah, usually like when we get together like as a team, we can like always do the A problem because we can read and code faster.
But like reading the problems is like anyone can be faster. Like there's not really like a skill to like read problems fast. So let's first explain the problems. So once you understand the problems, like we can explain the problems first before jumping to the solution. So there are two end pins. Okay. Uh, okay. 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 Oh, I see. Okay, this is not as obvious as the first day problem. Um, hmm. So basically, like you are given. So first, it's guaranteed that. Oh, wait. Okay, so there are two end pins in a circle, and then there are like end strings. Each pin is connected to exactly one string, and then you want to restring so that the strings are parallel. And one step is defined as detach one end from the string and then reattach it to a different pin. Okay. And then during the process, obviously, there might be some pins that are connected to multiple strings, but that's fine in between the process. Okay, got it. Hmm. So basically, there are only n. Are we good on the problems, Klungs? Do you understand the problems?
Yeah, I think so.
So there are only n valid strings, right? And um, like basically, once you decide like which pin the string that connects pin 0 should go to, the rest is like fixed. So like there's only n possible like strings and possible like what is it, configuration, I should say. So like if you can try each of them, like that's n square. Oh, is it basically just count like like for each of the string that is initially placed, you can find like the difference. Basically, like maps like for each string given in the initial input, like you know which string this maps to, like which configuration, which possible configuration, right? So like for example, like because there's only at most n configurations, right? And like basically the gradient, you start the gradient for each like initial, and then like you you choose the gradient that appears for most lines. Is that like the optimal? That should be the optimal answer, right? So like basically for each line in the input, you store the gradient, and then like you basically keep the gradient that has most lines. Of course, some gradient is not valid. Like if that gradient is like, let's say in this example case, like this 0 to 8 is actually not a valid gradients, because if you do this, you can't string all of them. Like basically the gradient has to like connect, like the distance between them have to be like even numbers of pins. Um, Basically in this input, like, yeah, you see that there are already like two lines here that connect 7 2 and 6 3 that has the same gradient. So like that is basically the answer.
But how do you represent the gradient though? It's just the difference?
Wait, is it just the difference? Um, I think the easiest is like for each line you represent it as which pin connects to 0 that has the parallel line as this one. So like for example, 6 3 represents to like 0 9, right? So I think that's actually the sum, right?
Right.
So basically, yeah. So like, okay, so basically this problem just like um for each line, if the sum is like um is it if the sum is if the sum is odd, right? I think if the sum is odd,
Yeah.
then you increment this into an array of the sum. Like basically you incremented the occurrences that this number appears, the sum appears, and then you just take whatever the sum that appears the most, and then I think the answer is just n minus that. Is that correct?
I think so.
Oh, but you have to construct the okay, it's a bit annoying, but yeah, I think that's basically the optimal answer. Um,
It's output. Okay.
yeah, like in this sample input two, there is no sum that appears more than once. So like the answer is basically 5 minus 1. And then this one, 7 appears twice, right? So like 4 minus 2 is 2. In this example, 12 appears. Okay, the sum of all these numbers are even. So that's why like you can't, like basically the answer is 6 minus 0, right?
Yeah. Yeah.
So I think that gives us the answer, the minimum number of steps. The placement, yeah, it's just yeah, I think you should be able to do it greedily, right? Basically, like for all the lines that are not parallel to these lines yet, basically we just like
Yeah.
basically we just iterate from 0 to n minus 1. If like currently the line that is connected to pin 0 is not parallel to this set of lines that we want to fix yet, then we just fix it, right? We just fix basically, let's say 0 connect to x, we just change the x, right? I think that should work, right?
Yep. Yep. Yep.
Yeah. Okay. Okay. Yeah. So that should be like yeah, ON solution. There's no sorting or anything here. Yeah. Okay. Okay. If you got the first number correct, you get 50% of the points. So that's interesting. Uh, yeah, out of 100 points. Okay. So I don't think we need to code this. Even if we code this, like we can't really check whether the sample outputs are correct, because there are many possible outputs, and the first number I think we just verified that it's correct. Yeah. Okay. So let's go to problem B, and yeah, because there's no place to submit it yet, I don't think it's worth to code that problem. Hey, I hope there's another interactive so that we can code something, because like interactive usually you have to verify with the testing tool. Um. Okay. Problem B. So it's a graph, basically. Okay. It's a directed graph. Okay. Okay. Every channel. Okay. Just the okay. 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 Hmm. Okay. So basically, for each node in the directed graph, we want to find the like the shortest path to node n minus one or the shortest path to node zero on the reversed graph, right? And between these two numbers, we take the maximum, right? I think that's the problem.
What? What? Huh?
Wait, what?
Is
Wait,
do
isn't
we
that
start?
just solving Dijkstra twice? What? No, I don't understand the problem.
I think the draw do the can do the operation between, right, like middle of journey, right?
Again?
So the troll can do the reverse operation in middle of the journey, right?
Right, on the beginning only, right? Oh, hey, wait, what? Each round? Oh, okay, so like after each move, they can do the operation, is it?
I think
After each
so.
move, they can do the magical power. Ah, okay, okay, okay. That makes more sense. Okay. Ah, okay. Yeah, yeah. I thought it's like they have to do it like at the beginning only. Okay, yeah. Uh, for but then can the answer be like infinite if like it's a long string and then we will keep reversing like if it's just a line from left to right and then they will keep reversing each round, then you have to go left, right, one step, right?
No, 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 no. Like the troll can only activate once. Once.
See. Okay. Where does it say that?
Second paragraph in bold, my man.
Okay. 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 But I assume that but I guess like this at most once is like Um, okay, but this can be different for each value of C, right? So the values of C are independent, and then like this. Okay, no matter when the troll chooses to use his power. Okay, 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 okay. Okay.
The C is like output for
Yeah,
all C.
and like for all C, like basically it's a different problem, right? And like the strategy for different values of C can be different or something like that for the troll. Yeah, okay, okay. I think I got it. Okay. Um, have you gone through any solutions here or just statements? Yeah, we went through problem A and discussed the solution as well. Now we are discussing from problem B, the second problem. It um is it just Dykes is it just Dijkstra, but the cost is like the current distance plus the distance from this node to like to node zero on the inverted graph? Does that work? So like Dijkstra usually the function the value that you push to the priority queue is like the current like distance, right? The current steps, right? The current number of steps, right? But instead of just the current number of steps, like basically the relax function instead of just current number of steps, like you also plus the distance that the shortest path that it takes from that node to node zero on on the reverse graph.
Oh,
Like basically,
wait.
wait, let me
No,
think.
but the texture won't work, right? If you do it like that.
Or wait, let me think of something else. Or let me put it this way. Like basically let we can okay, let's say a function du is the shortest path from node u to node zero in the reverse graph, right? And then basically we can um like for any edges going from u to v, we can set that edge weight as dv minus du. Um, and then the answer for a fixed value of c is just uh, dc plus the shortest path from node c to node n minus 1.
So you force the guy to go to node n minus one first, then is that the idea?
Uh, wait. So basically, the tricky thing in this problem is like if like there's a node here, there is a node here, and then like there is a like several nodes here, and then there is like a longer path here. Okay, so let's say this is n minus one, you'll probably use.
Oh,
And then like, but there is like, this is node 0, and then like there is an edge going out to all this. Then the optimal answer is like take the bottom part, right? Because like if you take the top path and then the troll uses the power, then you are screwed, right? Um,
really, what happens if we are screwed?
wait, sorry. Does
What
is
is
it
possible?
guaranteed that from node 0? Oh, sorry, from node 0 you are guaranteed to go to all nodes. Then yeah, there is an edge there as well. There must be an edge there as well. No, but I mean by screwed, like you have to go back all the way to node C. So that becomes more expensive, right? So like
Uh,
in this like, so this is where it differs from like normal shortest path, that like you don't just need to go to node n minus one, right? Um, okay, but what I was saying earlier is that okay, let's use the sample case. Um, so basically, can I use a slightly thinner pencil? Okay. Probably use my tablet. So if we have like a 0, 1, 4, then 3. Yeah, basically the idea is that like you want a short, like a normal shortest path problem, but like if we go back to the first, like this example that I just showed you, like we don't want the top path, because like if we go to the top path and then they use the power, like this will become expensive. So we can give like a boost to the bottom path by like basically instead of just the current step, it's like the current step plus the distance of node u to node 0, right? So that if we do the extra on this, we will prioritize the bottom path first. That is like my idea. Um, so for this one, like if we just use the edge weight that I mentioned earlier, then the edge weight of this is 1, because like from node 2 to node 0 is like one further from node 1 to node 0, right? And then this will become 1 as well. This will become 1 as well. This will become 0, right? And then this will become 1, and this will become 1, right? And then you run shortest path on this graph. Well, basically the edge weight on will be either 1 or 0, right? Definitely. Because right, if you say like there is a no there's an edge from u to v, then like distance v can only like either equals to distance u, or oh wait, it can be less as well, yeah. Oh, never mind, it can be less as well. It's like either 1 plus distance u, or equal or less than distance u. So it can be negative edge. Uh, okay.
I don't know. Doesn't sound correct to me.
Okay, let's ignore the negative. Oh wait, it should be 1 plus dv minus du, because like you need to pay one cost for going through that edge as well. Um, yeah, basically the idea is like if you go through this edge, right? Okay, first initially you pay dc first, right? This is like in case they suddenly like use the power, right? Uh, and then like if you move to another edge. Oh wait, but then if they, okay, never mind. Yeah, this is very wrong. If they didn't, if the troll didn't like use the power at all, then you pay like DC plus something, even though like you shouldn't pay it all. You should just pay all the edge, like all the ones, right? Yeah, yeah, that's not correct. Okay, yeah.
Maybe try to find the naive solution first, the n squared
Um,
and cube, I guess.
but once. So, so if you reaches the node n minus one, then you can immediately exit it. They don't have time to like activate the spell after that. Okay. Um. Yeah. So like okay. So if you okay, let's answer for each value of c in on first, like an n square solution first. Then if we do like a binary search the answer, so let's say whether we want to check whether like it's possible that the answer is like less than or equal to C, right? Then okay, let's not use C. Let's use
EQ.
like K, whatever, right? Then can you just like run Dijkstra as normal, but if you visit up a node, when you're trying to like pop a node from the priority queue, like when you're trying to like process this node, like basically relax all the edges starting from this node. But like if this if the node like the current distance plus the distance uh the distance from from that node to like zero to the on the reverse graph is like greater than k, then you don't relax this node. Does that work? Like basically it's like you can't visit that node. So like if you're trying to relax that node, you can't. You don't relax that node. If the current distance plus the distance to go back from that node to node zero is like greater than k. Do
Yeah, I
you
think that
understand?
works. Yeah.
That
Yeah,
should
yeah, yeah.
work, right? Yeah. Okay. Um so to answer all value of C, um okay. To answer the value of C, to answer the answer for every C, Can we just, okay, reverse the graph? Um, and then like the relax function, basically the usual relax function is like dv equals to like min dv du plus one, right? For each edge u to v, right? Instead of this, we do like dv minimum of dv and maximum of du plus one, uh, the the distance from node v to node zero on the reversed graph. Is this correct?
Let me try to read your thing.
So basically, like if go back to the example case, okay, this is the example case. Then like okay, there's no edge weight anymore now. Let's like throw the idea of using edge weight. Okay. We know that the value of D4 is zero. And then basically when I try to relax this, I relax it to the maximum of 0 plus 1 and the distance from node 2 to node 0 on the inverted graph, which is 2. So this is now 2. And this is 1 because it's a maximum of 1 and 1. Okay. So this is now 1, this is 2. And then as normal Dijkstra, we process the one that has the lower value of D first. And then we relax this to maximum of 1 plus 1 and 1. And we relax this to 0, 1 plus 1. So it's like this is 2 and this is also 2. Now we relax all these 2, it won't change anything. So like this is the answer basically. If we start from here, it's 2. If we start from here, it's 2. Start from here is 2. Start from here is 1. Start from here is 0. And it's correct, right? Yeah, it's correct, right?
Magic.
So basically like, okay, we run we pre-compute the this function first, the distance from node feed node 0 on the reverse graph, which is basically run the extra from 0 on the original graph. But after that, we actually don't need to run anything on the original graph anymore. Right? Does this sound right to you?
But I still don't understand what you're trying to do. Can you explain again? Like,
Yeah, it's basically this. Which one you don't understand? Like the normal Dijkstra is basically right. You set the source to be like 0, and then the other nodes to be infinite, and then like, and then um, and then you run, basically you keep iterating, like you keep choosing a node that has the lowest value of d, right? um but you haven't visited it before, and then basically for, and then let's say that node is x, and then like for each edge from x to y, you like do a dy equals to like minimum of dy comma dx plus the edge weight, right? This is normal Dijkstra, right?
right, yeah.
Yeah, and then instead of doing this, you do this.
What is the starting source?
N minus 1. We run this on the reversed graph.
Right, I see. Oh, oh. Yeah, I guess it's correct.
Yeah, this should be correct. Um, You did that as I did that as well. BFS from node 0 to V. Yeah, the this part is basically like you can run DFS to pre-compute this. Like this dv0, you can use DFS to pre-compute that, and then I do the DP that I described. Okay, yeah. It's not exactly a DP. Like in a DP, you can't handle a cycle. This is a Dijkstra, not DP. Because like in a yeah. Um, yeah. And like most importantly, this works like these complex functions still won't be smaller than the value of du. So like if you have a if your function like in Dijkstra, the tricky thing is like if you have a function that like if your relax function is like dv equals to like minimum of dv and then something that like can be something that can be like less than du, like du minus one or something like that. Like this will basically like won't work because it's as if like you're running Dijkstra on a negative edge graph. But this function here, you max it with du plus one, so it won't be smaller than du. Like the problem with like relaxing it to the value of du minus one, like you can't greedily relax the nodes anymore. But this should work, yeah. Do we code this?
Really, does this handle the automatic exit like reach n minus one?
Yeah, because yeah, right. It's sure, right?
I guess it's yeah.
Yeah,
We start from there. Yeah, okay.
yeah. Okay, wait. That's it? No, wait. It's so basically like if it's a line, the answer for the middle node is one, right? And this algorithm should also return one, right? But if the magic spell can be used after you reach n, then it will three. One, two, three. Yeah, yeah. Should be correct, right? Yeah. Oh yeah. By the way, on day one problem D, yeah, like on last stream we discussed like a combination of Mo algorithm with dynamic MST. So like there seems to be a dynamic MST solution that takes like log n like in the order of like q query log query solution, query plus number of edges times log number of query, um or something like that. So yeah, our solution becomes n square root n log n, or to be more precise, I think inside the log there should be square root n as well, because like we have that many queries, or like that many updates, I should say. Like right, basically like we have n square root of n like number of updates. So then like if you use the dynamic MSTs become like this, which is even worse than n square root of n log n. But yeah, anyway, um, yeah, probably TLE. But okay, let's just move on problem C. Should we code this? I don't think the code will be that difficult, right? We can try, right? Okay, Clones, you help me proofread my code.
Okay. Be Python.
No, I don't want Python on this one. Sorry, no. Okay, and then like we can like distance from 0, let's say. And then we can have the adjacency list and the inverse of the adjacency list as well. Okay, and then we can set this in max, let's say initially, and then we loop the edges. Let me save this file first so we have syntax highlighting. Okay, and then we run a DFS from uh, 0, right? So um, how does this work? Um, if distance is not in max, add it to the queue, right? Correct. Yeah, correct, right? Okay, and then you have to use Dijkstra, and now this is the real answer. Okay, let's just use answer then. Um, then priority queue. Okay. Uh, and then the answer for no n minus one is 0, and then we can push.
So use the minimum priority queue.
Yeah. What is the syntax of that? I don't remember the syntax of that.
Vector pair in and greater pair in.
Wait, say factor first or greater first?
I think vector first. It's been a while. Let me check.
Yeah, I never memorized the syntax of that. I always just negate it.
Oh,
What? What? Oh,
like use minus or something.
yeah.
Oh my god.
I always do that.
Uh,
Okay, now I don't need to
monsters.
anymore. Okay. Answer n minus one, n minus one. Well, empty. Uh, take the top second. Uh, top. Um,
I think you also need the first, right? To pick your toplet first.
uh, you can just wait. Does it work if you just? It's basically the same as answer, right? Yeah, I usually use a
Oh
done
yeah.
boolean. Okay, let's just
So
do that. It's easier. Um, then if I have a done function, it's just simply like if done you or continue, done you true. Yeah. No, I don't want to buy Sublime Text. Um, not now. And then uh, and then this basically, yeah, the if like the good thing about like using this done, like I can just push it to the queue however I want. Like I don't need to like this one, for example, I don't need to like have this check. Um, answer. Oh wait, yeah, like okay, there is yeah, okay. Um, fee, okay. And then what? Answer v equals to minimum of answer v, the maximum of answer u plus one, distance from 0 u, no v. right? Right, the sidebar. Um, need to check whether this increases the. No, I can just push it to priority queue. I don't care. I mean, we can optimize it so that only if it decreases the value of answer fee, then we push it. But because we have this if done thing, then should be fine. Um, it's just a bit slower, but shouldn't be problematic. And then we not print. Okay, I guess the value of n minus one will be zero. So I guess that's why we don't print. Okay, that is this correct? Do you spot any bug?
Easy. Looks correct. Only zero.
Hmm?
Jump scared by zero.
Wow!
Huge.
Wow! What is the value of distance from zero here? Want to print that out first. This graph, yeah, okay.
Oh, I think you have not.
What?
You have. You haven't set done n minus one to true.
Okay,
Oh
yeah,
wait.
sure. No, no,
Mind.
no. It will be done
Uh,
here. Fine. So the distance from zero is not correct. Zero.
uh,
The all the thing is
that if is wrong, should be
hmm?
equal to in mac.
After
Oh, still
that
wrong.
is the distance from zero, zero, one, two, one, and then I didn't print n minus one. Okay, yeah. Okay. So that is fine. Answer 2 to 1. Correct.
Easy. Easy.
Easy. 1, 2, 3, 2, 4. Yep. One, 4, 3, 2, 1. Yep.
Hey.
Okay. Let's do problem C. IMO. Okay.
Wow, the first paragraph is like nothing. It doesn't
Yes.
say anything.
You just like waste like a minute of your life reading that.
Oh my god.
Wow. With ties broken by the contestant in distress. Wow. Very fair contest. Wow. Okay. Interesting. Wow. Okay, so basically the problem is about like um basically there is like a table of R times C whatever, and it is known that the value in each cell is basically between 0 and k, and like we want to rank the rows. Basically the rank of each row is basically like the sum of the values in the row, and then the rank is basically, yeah, like how many other rows have total sum greater than its sum. And then if it ties, it breaks by the row index, and then basically we want to refill the smallest set of values in the table so that whatever value is not revealed, as long as they are in 0 to k, the rank is still, there's only one possible rank. There's one only possible permutation of rankings basically. N times m less than equals 16. Oh yeah, I guess a 2 power of something works, right? And then n square, and then, oh, okay, basically like the brute force is like you make sure that the order of two rows are the same basically. If like row A is greater than row B on the input, like when you hide some values, like you can also make sure that even if you put all zeros in row A and you put all k in row B, row A still has to be more than row B, right? So that's the brute force. That's like the 2 to the power of n times m, right? Times r square or whatever, right? To check.
Yeah, yeah.
That works, right? So like you can, to check, like you don't need to like brute force the value of the cells, but like you can only check that like the order of each pair of rows is still the same, right? Does that work? Like the relative ordering between two rows. So like to check whether like a set of hidden values is okay, like you can just brute force for each pair of rows.
Yeah, I think that works.
That works. Okay.
Does that work for only consecutive rows?
Oh, I see. I see. Yeah, that works. So the brute force can be like ON only, right? OR, whatever the number of rows,
Oh,
right?
oh,
When you
yeah,
say
yeah.
consecutive, it's like consecutive in the ranking, right? Not in the input, right?
Yes.
Okay. So so there should be like uh no. Um oh yeah, then like there is a n times to the power of m solution here, right? Where like if you just do like a bitmask TP, like you go from the smallest rank row to the largest rank row, like if you know what is the subset of values hidden in the previous row, you know what are the possible valid subset of values to be hidden in the current row, right? So that is a bit mass DP, right? Do you understand what I'm saying?
Uh,
Right? Because we only care about
oh,
consecutive rows. Okay, let's say we already sorted the rows based on the ranking because the ordering of the rows doesn't matter, right? In the input, let's say we
yeah,
already
yeah,
sorted based on the sum of values. And then basically, yeah, basically to in order to like determine what are the set of values to be hidden in the current row, you only need to care of the set of values hidden in the previous row, right? Or or even like we just care about what is the sum,
yeah,
um, right? Sum of the values that are revealed in the previous row plus k times the number of values that are not revealed, right?
yeah.
So that is um, n times n square k solution, something like that. Um,
Yeah.
no, sorry, n times m times k. Sorry, not n square k. N times m times k plus. Okay, the transition might be a bit annoying, um, but yeah, that should solve subtask 5. Even if the transition you try possible subset, that's 2 power of m times k on the previous row, the state of the previous row plus uh like whichever row you are currently in. That's the state, right? So that should solve subtask 5 and all
Yeah.
of the subtasks before as well. Um
Eh? Oh yeah. Eh, no.
no, subtask 2 and 4. Okay, subtask 2, there's definitely an easy solution. Uh okay, how do you solve subtask 2? Okay, anyway, I don't think the solution for subtask 2 is like useful for the full solution. Like it's like with 2 rows you can probably like hide the smaller values in the winning row or something like that, like greedily. Anyway, I don't think it's important for the full solution,
Yeah.
so we don't really need to think about it. Yeah, like it's a very special case. Um, yeah, but I think like we we have managed a DP that the state is like n times m times k, right? But the transition, like then we need to figure out how to make it to a one transition. If we
Yeah.
can do that, that will probably fit. That is like 200 million. What is the time limit here? 6 seconds. Yeah, I think that will fit. So basically, like with that DP state, we just the isn't this the winner of the previous EGOI, the problem author? Anyway, yeah, but like if we can if we can figure out how to like make the transition of this DP01, then we should be able to. Then this solution should work. And how you do that is basically like the the hmm, hmm, go to the whiteboard. Okay, so a DP like this is the row index, and this is like the sum of the previous like row. This is basically like okay, let's say this is the we want to compute the maximum value of cells that we want to show. Then this is basically like maximum of like the subset of all possible subset such that the among like the subset and like the condition is like the sum of the subset must be greater than or equal to phi, right? The greater than or equal to depending on the index of the row. But then among all subset that is greater than phi, like we take the size of the subset. Wait, sorry, no, minimum. We want to minimize the values that is revealed, right? So this is minimum, and then like the size of the subset plus dp. Oh shit, it's r plus one, and then the second value is like slightly more complicated. Okay, it's like the sum, but then no, it's like sigma of the revealed plus k times the number of columns minus the size of S, right? Something like this, right? Um,
Yeah.
and then basically the good thing here is that if the value of phi increases, this S is just basically becomes smaller. It's basically like become a subset of what is previously possible. So like in order to compute the value of like dpr phi, we can just it's like a minimum of like dpr phi plus one, comma this function such that this is exactly this, something like that, right? Um,
Yeah.
yeah, this is equals to phi plus dpr plus one sigma s plus k p minus s, right? Something like this, right? And basically this sigma s becomes phi. Okay, this sigma s becomes phi inside here, right? So now so basically we just want to find uh, one single value of s. Okay, let s be the set such that sigma s is phi and like the sum is no, we can't greedily minimize this because then this will be big. Oh, okay, so we can't really be too greedy on that. Hmm. PPR is it's increasing, right? The
Uh, Fee.
yeah, like as phi increases, this increases, right? This function. So like yeah, okay. So like choosing a single value of s doesn't work because like if you're trying to yeah, if you're trying to like minimize this, then this increases, right?
Yeah.
Am I right? Yeah. So like you can't just greedily take the s that is like So yeah, basically I was wondering like, can we just take a single value of S that like minimizes the number of cells? Like yeah, like we can use knapsack or something like that, right? To do that, like to like check what is the minimum number of columns that you have to refill such that the sum is phi. But then if you only refill a smallest number of cells, then for the next row it becomes problematic, right? Because then yeah, okay.
Hmm.
But then um we can change this instead of like all subset. We can think of like a minimum of like um 0 I C, right? Among all those, like if there is a subset, if there is a subset with size I that the sum is phi, then we can do this, right? And we can, I guess we can check what are the possible values of I using knapsack. A
Yeah,
times
but
E minus I.
I
Yeah, but
think
this is
the
like, yeah, this is RCK T square, right? Yeah.
yeah
Um, mhm.
expensive.
Hmm? But at least we don't have to iterate subsets anymore now. Um, oh wait. Oh, across all value of V. Oh no, no, it's 2 to the power of. Oh, okay, never mind. No, I was thinking like, yeah, like for this one, even though like we have to consider all subsets, but then like the number of subsets that we have to consider, like for all P combined, it's like 2 to the power of C, right? But C is 100, so we can't do that. If C is like
Yeah.
a smaller value, then we can do this. Yeah. Um. Okay. Among among all, wait. Yeah, I think like if you can hmm, among all the subsets of 2 to the power of C, if you can group this based on like a pair of value like the sum and the number of elements, still very tricky. Never mind.
That's too large also because number of table is n times m. A.
This is
M
like
square times k. Yeah.
C times K, and this is C. Um, hmm. Oh, I guess this solves subtask 4, yeah. Because like subtask 4 with k equals to 1, the only subset of fail okay, not really. Well, it is, but it's slightly complicated because like basically we know that all the subset all the subset that equals to phi, like we know that the size of the subset can be the size of the subset is like fixed between like phi and like phi plus the number of zeros in that row, right? Something like that. But this thing is
Yeah.
a range, is a the possible values of size of x is an interval, right? So we can use some data structure to to find a minimum value among all these possible size of s, right? You get what I mean?
Yeah. Kind of. Yeah.
Yeah. But the problem with like if k can be if the values in the table can be non-binary, then the possible values of the size of s can be non-interval, can be like any set of any subset of like values from 0 to c. At the scoreboard, there's only two contestants that solve this. Hmm. Hmm. And 72 is basically only left with last subtask. Okay, yeah. Which I think we can do. 72 should be possible. Like some kind of like the square root technique where like you do a knapsack. So like basically the in each row, instead of like storing the values in each column, you can just store the occurrences for each value, right? Like in each row, how many times 0 points come up, how many times 1 point come up, and so on, right? And then
Yeah.
there's only at most like a square root of k distinct values of that or something like that.
Yeah. Huh? No.
No.
If it's all given,
No.
if everything is given,
Yeah. No, I mixed it up with something else. Sorry. If it's like the square root of the sum. Yeah. The sum is not bounded by any value. There like a bound on the sum?
First paragraph is
Yeah, it's like I think my best solution right now is like times. Yeah, I think I can do something like this. Basically, like going back to my idea where like instead of iterating the subset, we iterate like how many values we want to refill. And then I think we can check whether for each value, like for each the number of values that we want to refill, we can check whether there is such subset using knapsack, and it should be like c square k as well to do the knapsack. So like the knapsack we can do pre-computation right before any of this TP. Yeah, but now we want to remove one factor of c. I don't know. Any idea? Clones?
still thinking, still thinking.
While I'm reading messages that there seems to be a live stream for the awarding ceremony tomorrow. Yeah, we can. Yeah, I don't know. I don't have any ideas yet. Can move on to the next problem, read it, and try to come up with some number of points for the next problem first as well, if you want. And then we can maybe go back to this if you have more insights while thinking
Sure,
about the next problem, maybe.
sure, sure.
Okay.
Up here. Lost.
Say again.
Yeah, to avoid getting stuck for too long.
Yes. That's what you should do as a contestant as well. Yeah. At least we should be able to get 78 points. Uh Even I think this complexity should wait, does it solve Does it get 78 points with that solution? Does it solve subtask 2? P square K. Yeah, it's sure, right? Yeah. Yeah, yeah,
Yeah.
yeah. Yeah. So we don't need to write a weird greedy for subtask 2. Okay. Okay. Laser strike.
The first paragraph.
No, I think this one is useful.
Oh no.
Okay. 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 Oh, this is communication problem. Okay.
Sounds like a co-op.
Hmm? Oh, okay. 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 So the tree and L is only node to N. Oh, N can choose the values of L, but the values of L must satisfy that it's a leaf every time. Okay. She will make the goal of the game is Catherine to remove from the board in the order. Okay. For move I, the pair of directly connected pieces numbers. Huh?
I don't get that. What?
A or B is the correct piece Li that should be removed in this move. There's still a pair of directly connected pieces. Oh, okay. So, okay. So N will tell Catherine A and B, and one of them is the leaf that you should be removed, and the other node is the node that is adjacent to that leaf. Okay, yeah, and because it is a leaf, then the other node is unique. Yeah, okay, okay, okay. Uh-huh.
Oh my. Directly connected.
Oh, okay, okay. I think I understand the problem. Yeah. So basically, there is a tree given by the judge. This is adversary. The tree is adversary, and then the first player who sees the tree, the second player does not know the tree. The first player have the tree given by an adversary. Um, the first player has to come up with a list of nodes to be removed, such that uh, every node when that node is about to be removed, that node is a leaf, and then the first player can like come up with the list, right? And then the first player will send a binary string to the second person. This is before any operations, like, and this, I think the goal is that the binary string should be as short as possible. And then at each step, the first player will tell the value of li and the neighbor of li, which is unique, right? And then the second player has to guess which one is the leaf. That's my understanding to the problem. Do you do you understand it the same way, or like, sorry?
Yep, yep, yep.
Okay. So basically, like there is an obvious n log n solution. How many points that will give us? What is this? Uh, let me check. Phase one. Train outputting a binary string. Oh, at most n. Okay, so you cannot, your binary string cannot be longer than n. Okay, sure. Okay, should output n. Okay, this order. Okay, and then this L will not be given to Catherine. The next line of input contains the binary string from phase one. Okay, there will be n minus one iteration, and then those will be interactive. Okay, A B wrong answer. Okay, yeah. Okay, okay. Okay.
Read the scoring though.
Say again.
Need to read the scoring as well.
Okay. For every test group that your program solves correctly, you receive score based on this. SG is the maximum score for the test group. NK is the maximum length. Will be rounded to SG is the maximum score. Okay. Wait, so you have to send only a binary value for the 100 points? Wow.
Oh.
Wait, how do you solve a star with only yes or no? With only binary when you send? Oh, I see. Yeah. Of course, of course. Yeah. What am I thinking? Yeah, I think it's easy, right? You just, yeah, okay. The yes or no is just like whether the central node is greater or lower than L0, right? Yeah. Right. So with
Yeah, yeah.
on the first query, you know which one is the star, which one is the leaf, and then once you know the central node, you can answer the rest of the queries. Yeah. Okay. The tree is a line. It's the same thing, right? You just tell, like, basically if the values of L is like sorted from left to right, then basically if you just tell whether L0 is less than L1, and then the second player will be able to deduce which one is L0, which one is L1, and then L1 and L2 will be given the next one, they will be able to deduce that as well, right? So yeah, uh, right? Okay, so those two subtasks, 17 points. The next subtask should already having more points, much more points. The tree is a star with lines going out from it. That is, all nodes have either one or two decent nodes. With lines going what does it mean? Except for one, all nodes have either one or two adjacent nodes, except for one that has more than two adjacent nodes. Oh, I see.
I guess like the leg of the star can be like super long.
Oh, right. I I originally thought it can only be two nodes. Sorry, yeah. The length of the lake can be a line, can be a long line. Yeah, okay. Okay, okay.
A minute, I will do toilet break.
Okay, go ahead. Let me know when you're back. Okay, I found a log n solution for subtask 3 that will give me about 70% of the subtask points.
Egg.
Yeah, I was saying earlier that I found a log n solution for subtask 3 that basically like you can do the legs like basically for each of the leg you do like a subtask 1, uh but then like you can do the legs that the index of the leaf is like smaller than the index of the parent first, and then like you encode in like log n to like indicate where is the split, like how many legs you do smaller first, and then how many, and then the legs after that the leaf is like higher, is like greater index than its parent. You should
Oh.
be able to do that, right? So
Oh.
yeah, you only encode like basically you want to send an integer between 1 to n, or more precisely I think it's n over 2. No, it's n, sorry, it's n, yeah. And then you can do that in log n, log 2 of n. So like that gives us 70% of the points of the subtask is 14, 15, 14, 14. And yeah, like basically the naive solution is not n log n, but you can do on basically for each, like for each round you just encode whether it's the higher or the smaller value between a and b, right? You don't need to send all the l values. Initially I thought the stupidest, the naive, most naive solution is to send the permutation l, but you don't need to, right?
Yeah.
So on is still very easy. You'll get 11% of the points. So much though. Um, you solve subtask 3 with only one bit? Oh, oh, I see. Yeah, I think I understand. Yeah, you can abuse you can take advantage of the length of the legs. Like basically, if you yeah, basically you can
Oh,
like you can keep the length of the leg in pieces, but then when you switch to like a leg that like the leaf is has a greater index than its parent, like so basically there's like two types of legs, right? The one that the leaf is like have a greater index than its parent or the other way around, right? Like we
yeah.
call it two types of legs, and then basically you go like in the order of increasing leg lengths, but when you switch the type, you also like decrease the leg length. Oh wait, but you can't. Oh, okay. You can't know the length of the leg until like you manage to answer that leg. Never mind. But yeah, I think yeah, like yeah, assuming like one type of the leg has like more than like one legs, basically then you can like do like from the second shortest leg first and then keep it increasing. And then when it's about to switch, like you do the shortest leg first and then you do the shortest leg. No, but what if the leg length is the same, yeah? Basically, like we need to be able to signal to the second player when it switches, right? When it's about to switch, right? Or do you have other ideas?
So I was thinking if the leg length is greater than 1 or
Uh-huh.
2, so you can, I don't know, maybe it's similar to your idea, but you can like, uh, can, can signal to like 0 or 1 by like sending how many like
Yeah, but that is log n, right? If you want to send how many, like that's log n right here. That is
oh no 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 no.
basically hmm?
So if you already know uh the first the first leaf in the leg,
Uh-huh.
you know that the next uh the, so you send A B, right? If you
Uh,
already know A is leaf,
uh-huh.
then you know that uh B is the next leaf in the leg.
Yes.
So technically like you can know like everything in the leg.
Yep. You can remove all that leg. Yes, correct.
Yes. And if you have more than 2 nodes in the leg, then you can signal to the next like, oh, is it like whether
Oh.
send one node or 2 nodes. And that determines like next the next leg.
Ah. Yeah. So if you like exhaust that leg fully, that means the next type is the same. But if you don't fully exhaust it, that means the next leg type is different. Something like that, right?
Something like that. I was thinking only send 1 or 0. I think
Yeah,
that's
yeah,
enough.
yeah, yeah. So basically, the hint is only like for to figure out the type of the first leg that you send, right? That is the
Yeah.
bit the
Yes.
hint is for, right? Yeah, I think that something like that should Okay, but what if it's a star? But what if all the lakes have only one node, basically? Yeah, I think that like if all of the lakes have at least two nodes, that's correct. Like you can control basically for each lake, like you can signal it so that the next lake is of the same type or different, right?
Yeah.
And then the hint is only to figure out the type of the first lake. Yeah. Um. Wait, but you don't know whether you exhaust the lakes or not, though. You need to
Yeah.
know.
So uh, I was thinking just like whether the first player will continue or not. If the first player like quits immediately, and
Oh, okay. Yeah, yeah, yeah. Okay, okay, okay. Yeah. But then, how do you handle the lake with one node?
yeah, I don't know. But I guess we can use like only two bits, right?
Yep, yep. Because you can use the first lake to fully exhaust it, and then once you fully exhaust it, you know the central node, right?
Yes.
Yeah. Okay. Yeah. Okay. So that's two bits. Yeah, you're correct. If k is two, log 10 of two, what is the value of log 10 of two? Like 0.301. Okay. So 1 minus 0.3 times 0.301. It's like 90% of the score of the subtask. Okay. Okay. What about the general subtask though? How short can we make the bit? Um, so subtask for basic, the diameter is at most 10, and yeah, like based on the score of the subtask, that feels like the main problem of this task, the main like idea, the gist of the problem. Um, okay, we know how to solve it in N. Obviously, um, Oh, there is a yeah, there is a 10 log n solution here, right? Basically, like if you do it level by level,
Is this the fourth subtask?
yeah, the fourth subtask.
Okay.
If you do level by level, basically like first you remove all of the nodes that are like at depth 10, right? And then because you can do it in any order, you can do the order like uh the smaller first and then the larger later. Then you can send a signal of again like how many smaller and how many larger, right? Do you understand what I'm saying?
Yeah, yeah.
Yeah. So that's 10 log n, right? Basically like you want to send or like times to 20 log n, whatever. You want to send 20 numbers between 0 to n, right?
Yep.
So that is like 100 or something. Log 1000 is 10, so yeah, about 100 or 200. So like that's about 39% of the marks. Only send one on the general tree, no way. Maximum points on this problem on the scoreboard. 43, 8, 9, 19, 4, 3. 8, 9, 19. Yeah, 19 on subtask 3 is basically the k equals 2 solution. And then the other two subtasks just get 4 points and 3 points. Okay. Which is basically k equals n. Okay.
For the like to start with the subtask 3,
Mm-hmm.
I just realized that you can send empty string. So
Oh,
that's huge. So just send empty string if it's star. Otherwise, do the algorithm.
wait. So like basically with k equals 1, you can send 3 possible values.
Yeah.
That to
Wait,
generate a
no.
string of
Oh,
length 0. Right? Wait, but if it's not a
oh.
star, okay, so but if it's not a star, how do you solve it with only one bit?
I mean, if it's not star, then you have to select with 2 nodes, right?
Yeah.
And with that, you can. Oh.
No, it
Oops.
doesn't work. No, I think it's actually the other way around. It's actually the other way around. If oh shit, no.
Oh no. But yeah, basically we can send 3 possible values.
Uh-huh. Uh-huh.
Sad. Oh, don't know why is it hard.
Just like no, I'm thinking like if there is if there is a leg with length one. Okay. So if there is not a leg with length one, that is done, right? That is simple, right? We can do a 0, 1, right? Yeah. Okay, but right? Oh no, 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 never mind, never mind. No, no, but that one is correct. That one is correct. If there's no if there is no leg of length one, then it's done. We can do it with 0, 1. Hmm. Yeah, I feel like the first leg you have to exhaust first so that you know the central node. once you know the central node, the basically all the leg one are basically free, right? So that can be ignored. That can be like answered later, like uh, and you know that they are a single node leg, right? And then basically, yeah, like basically we can use the property of like even or odd length leg length that we choose for the first one. But then what if all the leg lengths are even, right? That's the problem, right? Or like all the leg lengths are odd, right?
Yeah. Mm.
Wait, you can arrange the failure of L whatever you want. Can you just make it so that it only changes type once? And when you change type is where you climb twice. But then the star shape. Uh, wait, okay, but I think if the input is not a star, that solves you can do it, right? Even if some of the lakes have only one node, you can do that, right? You can do it such that you change type when you climb twice.
Yeah.
Yeah, okay.
Wait, actually, if uh if
So yeah, like between type one and type two. Okay, let's say the input is not a star. Between type one and type two, which one has like um which one has a lake that is not that has like longer than one node, right? Then you do that one first, and then you keep the long leg at the end, and then when we need to switch type, that's when you climb like twice or like all the way to the yeah twice basically twice. Yeah, it has yeah. So that works, right? But then the problem is if it's a star, if it's a star, then No, but if it's a star, you can easily detect because like the first two queries, the values of the value will intersect,
Yeah.
right?
Yeah.
Yeah, so that fully solves the problem, right? Sub plus three, I mean, sub plus three, right? Yeah. You don't even need to use empty string, right? Am I correct? If the input is a star, by just from the first two uh queries, you know that there is a common point. That means that node is a central node. That node is a central node. And if it's a star, then you know for all queries, if there is a central node, just answer the node other than the central node, right?
Yeah.
Otherwise, then you can do where you switch type when the query like climbs twice, right? And the 0 and
Yeah.
1 is basically
Yes.
the bit is to
Yeah.
signal which type is the first query.
Yeah.
Yeah. Okay. Too complicated.
Wow. 1 points.
Okay.
Why is the distance between two nodes is important though? Why is that so plus 4?
I mean, yeah, we just found uh, a a a suboptimal solution for that, like subtask, right? We just found a 40% point solution for that subtask, right?
Yeah, but I feel like if you can solve that with k equals
Oh
1, then
yeah. I think that's
you
correct.
solve
Yeah,
the whole thing.
yeah. But maybe the reason that subtask is there is like because there is a 40% points for that subtask, not because like
Oh,
there is an intermediate step.
wow, ultra strong. So 40% of 36 is like in
Like 14, not bad.
14. Okay.
Yeah, I don't know. And times interesting problem though. Oh, yeah, I think the best I can do right now for subtask 5 is like an over 2. Like basically like a solution that is like just the number of leaves is obvious, right? You just tell whether the leaf is like higher or not than the parent. And then like you can do n over 2 because like if there is like basically if it's a star you don't need to like you only need to tell one of the hint of like one of the leaf, right? um so basically if there is a node that has like two leaves, if a node is like a parent of two leaves, then you actually only tell you only need to hint one of them. And then basically if you assume that there is no such parent, then there's only at most an over two leaves.
Oh,
So like that is 500. That is like 20% of the points of the last subtask. 5. Yeah, no idea. Um, Someone mentioned MCMF on C. It really MCMFable?
want to go back to C.
Don't have any additional insights though. But yeah, MCMF is something that I haven't really thought of. But does that work? The mod. Nah, no idea. Don't know how the if it's an MCMF, I don't know how. Yeah, no idea. Yeah, I think so. Currently, we will get something like what, like 100, and D is about 72, not about 72, exactly 72. Then problem D is 8, 9. I think we can solve 21 as well. Then this is about, I said earlier, 14. Then the last subtask, percent of 26, 5. uh, 7 on the last problem. 3, okay. Huh. Our current score is about 3 to 9. Testing work for this completion problem. You definitely need to write to code, right?
That one.
Oh, it's the same code. Ah, I see. The same code, but then P is either 1 and 2, or then, okay, yeah, that makes sense. That's why you can just run the same binary. Yeah, okay, that makes sense. Yeah, yeah.
Oh, oh, I see.
Because you just need to submit one code that like implements both depending on the first number in the input. Yeah. Three to nine, that's close to rank one indeed. What is this? 311? No, but this is only okay. Someone get 326. Yeah, so yeah, because of C. Hmm.
Problem D is more fun though. I
Yeah,
like problem
yeah,
D
yeah,
more.
yeah. Problem C is like, I mean, depends on what kind of person are you. But like if you're not familiar with like a lot of CP techniques, then these should be more fun. Like C, I can imagine it's like some DP optimizations. Um,
Yeah.
yeah, and D is like probably like, yeah, like pure ad hoc problem. reference for the dynamic MST algo. Yeah, I'm not fully familiar with it as well, to be honest. I just there seems to be like a discussion in code forces. So if you just Google like dynamic MST code forces or something like that, okay, the
Let me
blog
copy
post is
paste.
called offline dynamic MST tutorial. I haven't fully read it myself, but
Oh,
then the claim is like it should be able to solve in like q plus m times log q. Sorry, you're saying something, Klunks?
oh, yeah. It's by Jeron. I
Yeah, yeah,
just
it's
copy
quite
paste the link to the chat.
okay. It's still TLE. Yeah, it'll be very very tight. Like uh, okay, we can talk about that, I guess. Yeah, so it's 100,000 and 100,000 times square root of 100,000 is about so like if this is x, basically the complexity is like x times log x, and that is like 700 million, right? Yeah, I mean, yeah, probably won't fit. But I think yesterday we got like plus 1, 2, 3, and then 6, right?
Yeah.
Yeah, so that's like 36 points plus 11, 19, 32, 46. Yep. Got like 346. You get 1, 2, 3, 6 as well. Yeah, that's what we got as well. Um, yeah, probably close to the first place. Uh, I mean, we don't have the contest pressure, but like, or maybe slightly above first place. 329 plus 346. Yeah, it's slightly above. But again, we don't have contest pressure
In code.
and we haven't code. I have a working code from day one AD. When it's available for submit, I'll just submit it directly.
Oh,
Yeah. And day two we have a working code for E. Right? Yeah. Figure it out once it's available for submission. Oh, it's already available? Where? Where can I submit solutions? It uh, don't have any guess. Where is it?
in code.
Where can I submit all this code? I don't think I can submit here, right? This is like the EGI server, so like I don't think I can even log in. If I can log in, the contest will already be over. So like I can't submit here. There's no way I can submit. Have they put it to like the open contest or something? Hmm, check your link. I don't see any link by you. I check recent problems on Kates. It's not in the contest list. Yeah, you probably can't send links on YouTube. I don't see clone's message as well. Probably censored.
Oh,
Yeah.
and
So even if I started, so this is the problems in OpenCut is, then like if I start by time added latest first, or no, UI problems. This by problem source.
oh, I found it.
Oh, where is it? Pro F
Uh,
wind turbines. Ah, there you go. So are the key problems? Okay. Yeah, I guess we can control it for problems. Okay, so okay, let's try that. Day one, what is day one problems? And then like all of my submission get 0 points. Day one, the first problem is if boxes. Ah, there we go. I need to log into my OpenCutlass first. Let me do it in another window so you can see. What is my password? I changed it because of the team contest. Oh, shit.
forget password.
Shit. Yeah. I might have changed for our latest team contest and then like I didn't change it back, I think. Where did I send that password? Okay, never mind. Let's just forget password. Your account, that thing, that, and then like the system will tell me that I cannot use the current password, right? That's like a classic problem of like resetting password. You're trying to enter your password, it says incorrect password, but then when you try to reset it, you guessed your password correctly. Try that. 5 minutes to reset the password. Let's try logging in. Okay, there you go. Press this page. Okay. Code is here. A.cpp. This is for problem A, gift box, start coding. Seems correct. I'll write for problem B, and then this is the problem that you asked me to code in Python. Ah, interesting. Okay, let me just submit what we have first. Monster. Okay, for Monster Go, I think during the stream yesterday, I just showed you a code that like proved that my solution is working, but I haven't coded the construction yet. But like after the stream, I actually coded the construction. Fine. Um, Yeah, so I think previously in the stream 2 days ago, I only showed this function, the DP function basically, but then I haven't coded this part, which basically uses this function to like actually construct the solution. Uh, but basically just by the DP function, it proves that like I can construct for all the answer of n. So put slightly. So instead of like printing for all values of n, I need to scan n, then just call. Didn't solve problem A. I solved problem B. Okay, great. Sure. Yeah, 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 yeah. Yeah, 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 yeah.
Oh wait,
But
I was thinking about problem D, right? But
which
like
day?
an the second day on what?
It's not correct. Oh, it's zero base. Okay, zero base. This
Classic.
should start with 49. No, 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 no. That- This should be minus one. Yep, 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 yep. It is a fun problem though. Annoying, weird problem, construction problem, where the input is just single integer, but then okay, so we solve A and C. Sorry, B and C. I guess I can debug this, or we can submit problem B for day two first. What is the title? Title.
I think it's not
For
there
us.
yet.
Not here yet?
I think so.
Yes, you're right. Yeah, I guess it's not Insta. Okay. Okay, so now let's just fix this code. What's wrong with this? I only get 19 points. Okay. Uh, I tried it right. Oh, this. No, this is correct. This is. Oh yeah, 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 yeah. It's possible that the answer is like 0R. I missed. Because here, yeah, here I didn't consider. Here I already started including I. So right, I will start from I plus one. But didn't consider. I didn't consider for L equals 0. Yeah, yeah, yeah. And come up with the test case for that. Um, test case for that. That you have to say um, something like that. 0. M first or T first? M first or T first? 701 201. I think the valid answer on that one, right? My previous code, I think I will print something else. 3.15 inches. Right, this should fix the bug. No, R minus. Well, it solves the first two subtasks too. Oh yeah, I guess with this can allow these subtasks. It works even if you ignore prefix. Hmm. Yeah, now seems to work. You're about to say something on problem D. What are you going to say? Plums? Sorry.
Yeah, so if once you already know the first leaf, right? And
Mhm.
always remove it until the last one.
Yes.
Maybe it's
Until.
easier to explain with picture
Okay.
or something.
Okay. Let's do it. Okay.
So suppose we already know this one,
Mm-hmm.
then we can remove this one as well, right? Because we already know
Mm-hmm.
this.
Mm-hmm.
And we can keep this one. Like we don't ask this. And we get actually like with length 2 that we can use for something.
Yep. Yep.
Yeah. And then we don't ask this, but we ask like the other the other leaf first that has the same sign as the first one. And remove. And then once there are none, then we can use this one to signal that, oh, changes direction. Yeah, and repeat the process.
Wait, okay. So let me scroll down. Um. Okay, so if you have, but what if you have like, yeah, but if you have something like this, right? Then what do you do? Oh, I see. Okay, but what if each of this is of length 2? Yeah, what do you do on this?
And it still work, right?
Can you explain
You
your
ask,
your algorithm again?
so you ask one of the leaf, say
Uh-huh.
this.
Uh-huh.
Actually, I think the order matters, but yeah,
Uh-huh.
you ask one,
Mm-hmm.
uh,
And then you
and
exhaust it until the parent is not a leaf, right? That's what you're saying?
yes,
Okay.
but in this case, like it doesn't work. Oh no.
Right? But wait, can you like can you do this? Okay, but there is a lock-in solution, right? You just send one number when so basically we just um yeah, there is a lock-in solution, right? Where you just do the leaves first because once you know the leaf and the leaf you can do it in order based on like increasing or like greater or smaller than the parent, right?
What do you mean?
So basically, let's say these nodes, the index is greater than its parent, and then this node, the index is smaller than the parent. Yeah, I'm stupid. Earlier, I mentioned an n divided by 2 solution, or like even like the more naive n solution or n solution, where we just send a hint for all the leaves, like what is like whether they are of the type 1 or type 2, right? But then because you can send these leaves in any order you want, then you can just send these first, right? And then by log n bits, you can know how many of these and these, right? Right?
It always like divide by two.
Huh? No, 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 no. You so basically here you're sending a hint that I want to send a number three, right? Because there are three leaves that the index of the leaf is, let's say, smaller than the index of the parent, right?
Yeah, yeah.
Right? And then after that, I send all the leaves that the index is greater than the parent, and I don't even need to send how many of that, because like once I completed all the leaves and then I move up to the parent, they will know that, like the second person will know that I start sending for non-leaves, right? Right?
Yes.
So this is an O log n solution, right?
What do you
For
send
the
as the binary?
yeah, yeah, yeah. To send number three as binary, right? I'm not crazy, right? And this
Oh.
is very simple to code also.
Wow, yes.
And this is like k equals 10. So like we got 70% of the points. And
Yeah.
this, even if you don't code the earlier subtasks, this is 70 points. And nobody got 70 points. I mean, we took some time to come up with it also, but then once we figure out, it seems like a simple solution. Or did we miss something? Nobody gets 70 points.
Turns out we misunderstood the problem completely.
I mean, I don't mind coding this for 70 points, and because there is a testing tool also, you should be able to like easily check whether this is working or not.
Oh, I feel like we are close to the
The full solution,
seventh
right?
one. Yeah.
Hmm. um, I mean, yeah, we can do like the thing again where like we switch when you climb twice.
Yes.
Okay, so if there is a leaf such that the parent is like also a leaf and that node is removed, then we are done. We can get 100 points, right?
Yes.
Right? Yeah. Yeah.
So
Okay.
basically, if every leaf in the original tree is discovered, like already removed, then GG.
Again, if yeah. No, but yeah, like okay. So basically, we want to figure out the type of leaf, right? That's the main problem, right?
Yes.
right? And then from our discussion for subtask 3 earlier, if there is a leaf that you can like make it climb twice, then you can use this climb twice thing to like switch the type, right? So like,
Yeah.
yeah, okay. So now if like, okay, let's say the problem has a special constraint that there is guaranteed a leaf that the parent is also a leaf when you remove that leaf, then we are done, right? We can solve the problem, right? Okay, what otherwise, if there is no such node, then if there is no such leaf, sorry, if there is no such leaf, it means like for all leaf, the parent has another children, right? Basically, right? Basically,
Yeah.
what I'm saying is if there is a leaf such that the parent is has only one child, then we are done. And then if it's not, then it means the structure of the tree is a not a star.
Kind of a star. Kind of.
Which question is going on? We're discussing the last problem of today, of day 2. What do you mean kind of a star?
Like uh it can be like a binary tree, right? Perfect binary tree. Like this.
Oh yeah, yeah, yeah. Yeah, you're right. Okay.
But yeah, if the parent has like more than one child, then
Hmm?
uh you can make one. Like I don't know. Like you can make uh snake, right?
By snake.
You see mine. Can you see mine?
Oh,
Let me
okay. Uh-huh, uh-huh.
if we have this, then we
Uh-huh.
can remove this and have this.
Oh,
And then this become like the two and move two now. Yes.
okay. So like you need to remove. So how does it work? By the way, you can use a thinner pencil by the way.
Oh,
On the
all
left, the
right.
stroke width. Yeah.
Right.
Um. Wait. How does it work too? But basically, if you want to signal like skip over twice, you need to remove other node first. But then that node can be of different type, right? So like if like let's say basically your idea like this and then this, okay, and then like this is of type 0, 0, 1, 0, 1, something like that, then you want to skip over twice, you have to remove all these node first, right? Which can be of different type. And
Right, but we already know the parent.
ooh, but what if they are
Since we know the parent, then like
yeah,
the other one must be the child, the leaf.
uh-huh. So okay, but how do we find such? Oh, so is it easiest to find the deepest child then, or something like that? I've backend database. What? Yeah, because like this thing might have something as well, right? If this is not like a leaf, then it's problematic, right? So I think it's easiest if we
Yes.
find the deepest child, the deepest node, which is definitely a leaf. Okay. So
Mm-hmm.
we found the deepest. This is, let's say this is deepest leaf, right? Deepest. Okay. There are two possibilities. Whether there is like
Mm.
also another node here or not. If not, then we are done, right? If there is,
Actually, what
if
happened?
oh, say again.
Why are we done?
Uh,
Forgot.
because if this node does not have another child, then
Okay.
we can use this as a signal of like when we process this leaf, then when it's about to switch type, right?
Oh,
Right. So we do the
yeah.
other leaves first of the same type as this, and then we end with this leaf, and then we switch,
I see.
right? Okay. So that is done. Um, but what happens if these deepest node have another nodes? Then
Oh, no error.
too big, it says.
Maybe. Yeah, it's not that simple.
No, no, no. I think we're close. We're close. Um, yeah. Correct, correct. If okay, otherwise, if this node has other children as well, then it's the same thing. We do we do the other leaves first that has the same type as this,
Okay.
including any of this if it's the same type, but it doesn't matter.
Oh,
And
then
then
remove. I see.
after this, and then you do this, and then you do this. Right?
Yeah.
That works, right?
Wow, good.
Right? Did you just
Yes.
solve this task? Is it 100 points? It is, right?
Maybe. But actually,
And
uh,
yeah, and the thing with the deepest is I want to choose the deepest node because like then we know that all these nodes doesn't have a children, so that we know that these other nodes definitely live as well, right? That's why I want to get the deepest node, right?
actually, wait. After we remove all the leaves,
Uh-huh.
uh,
Uh-huh.
we get the answer for this one.
Yeah, because yeah. Yeah. Because you know this node has appeared before. Oh.
But we don't know if it's, you know,
Oh shit.
sad. Well, quick solve.
Shit.
Sad.
Ah. No, we are close though. We're definitely close though.
Okay, is it possible to always maintain the lake?
What?
Like is like it always possible to maintain such that can always move up twice?
Can you repeat that? I don't get it.
Is it what to say? Because I was thinking we can always remove
Wait,
everything such
wait,
that
wait. Sorry. Because of this problem, that means only figuring out the type of the leaves is also not enough, right? Because we don't know when it
yeah,
switches from the leaves to the parent and the parent to its parent, right?
yeah.
Yeah. Oh, damn.
Yeah. So I was thinking like we do the move up twice thing,
Hmm?
but to figure out like all of the edges, as all the leaves.
What do you mean by that? Throughout the edges of the leaves. Wait, okay. So going back, the log n solution is still is that doesn't work then. That okay. The
Yeah,
70 points.
that's
Okay,
about.
yeah. Yeah, okay. Okay, let's go back to that one first. Okay. Let's say we know the answer for the leaf. As long as there is still more than yeah, as long as there is still more than two nodes in the same height, then we can alternate between those, right? So uh like let's say uh yeah, basically let's say this is at a certain height, okay? Okay, I don't know about the above, but let's say there are two nodes here. Then like once we know the leaves, like let's say this is the leaves. Yeah, then let's say if we know the leaves of these nodes, then we can like um go depth by depth, and then like we can do like this node, and then like this node, and then if we do something like this, then we know when it changes depth. That's what I'm trying to say. Because like like for each node, right? When you process this leaf, you eliminate this leaf, this leaf, this leaf, this leaf. And then when you query this edge, it won't be consecutive, right? You will go to other set of leaves first. So you know when it breaks between like processing this node as a parent compared to like processing this node as a leaf. Do you get what I'm saying?
Yeah.
So like I feel like once we know the leaves, it still works somehow. As long as basically like whenever you're like removing leaves, you don't immediately remove the parent as well. Basically, when you're trying to remove a node, you like the previous query must not be removing one of the child of that node. And I feel like it's always possible as long as the remaining tree is not aligned, right? Or something like that. Okay. Anyway, sorry. Do you have what's your idea? What's your thought?
Actually, it's uh, I'm starting to question the idea of moving up twice. The moving up
Okay.
twice. That work?
I mean, for subtask three that works.
Or because we know that the central node is won't be a leaf. Uh,
Yeah. 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 Like, wait, what? Yeah, we will never remove the central node, right?
it's hard.
Wait, no, the two lock n solution should still work. Oh, no, okay. I think I need two lock n instead of lock n. If you send all of the leaves information, so once you know the leaf, but now you need to log n because now you need to know when the leaf ends also. Like let's say you know for all the leaf what are the types, right? Then it should be fine, right? Because you can easily distinguish between like if you are removing like once you remove this, and then you query this edge, you know that this node is not a leaf, right? So you know that now you're trying to remove this node, right?
Okay, but then you need log n for every depth.
No, you just need wait. Let me think. Oh, you can't distinguish. Okay, doesn't work, yeah, because you can't distinguish something like this, yeah. Basically, okay, yeah, no, no, it doesn't work. Yeah, I think you need every tab. You're correct. Can't distinguish between these two. So once you remove 3 and 4, and then the query 1, 2, you can't know one is this. I mean, this is exactly the same tree, but once you have something else,
Okay.
no, but I mean, like, if you have something else here, but yeah, like, basically,
Yeah.
okay, so what's working and what's not working right now? No, 10 times 2 log n still works. This still works. For subtask 4, subtask 4, this still works, right? If we just go from bottom to
Yes.
top, right? So this still works. Um, you can remove the times 2. Okay, figure out a way how to remove times 2. Um, hmm, hmm. There is an offer to Natalie. Yeah, I'm trying to like thinking of a direction where like the order of L, you make it so that the number of switches between like type 1 and type 2 is like the smallest as possible. But then, yeah, okay. But then if it's aligned, then if it's aligned with like alternating even odd, even not like even odd, but like if it's aligned with alternating like um it's aligned and the indexing is like one, what is it? 3, 4, 5, 6, 7. If it's like something like this, then be a problem. Like, right? Do you know what I'm trying to do? So like basically like we order this in such a way that like maybe like the switches between like okay, for this one the answer is like the minimum between A and B, and then this one is the maximum and the minimum, and then the switches, if we can make the switches as small as possible, then we can just send the length of these each like log n, right,
Mm,
like
yeah.
right, and then basically like this is basically my idea for like subtask 4 where like you can make this only like have 10 segments only, right?
Mhm.
Right. Uh, yeah. Uh, but if the diameter can be big, then if this is the tree, if it's a line tree and the number is like alternating between high and small numbers, then this there will be like n over 2 segments.
Yeah.
So that won't work as well. Oh wait, does that work though? Hmm. Oh yeah, I think that still work. Like drawing something small. Okay. Um, that doesn't work. Yeah, basically, yeah, the earlier thing that I do, I guess, like now these two, 1, 2, 3, 4, and let's say one has a parent, and then like compare that to like 2, 3, 1, 4, and then this has a parent. Yeah, after you eliminate 3 and 4, there is a query 1, 2. You don't know which. Yeah, you don't know which one is the parent. Yeah, because like this node 2 and node 1 is like similar in the sense that there's one children, so like you can't really distinguish node 1 and 2, and then either of them can be the parent. No, no more idea. Problems for this day is to open cut this. Hmm. Yeah. Cursor right now. I can't find you.
It's at the bottom. Right, to the right.
Oh. Okay. I think for 3 hours. Wow.
Wow. Last idea.
What? Yeah, I think it's about right that basically if we are competing, like we're probably getting the number of points that we mine solved. Like basically it probably takes 2 hours to code all of this. Uh maybe less, but plus some buffer in case you're like making a lot of bugs or anything. And I think the 71 points or 72 points, whatever for problem C won't be that easy to code as well. So like and then problem D we basically need to like implement several solutions to get like the points that we discussed earlier. So yeah. Um yeah, I don't have more ideas.
It's an idea. I have an idea.
Okay. Okay, go ahead.
Oh, we erase this. So in a tree,
Hmm?
there are always like at least two leaves,
Yes.
right?
Yes.
So so is uh and we ask the any of the leaf.
Huh?
So here is my algorithm. Right?
Uh-huh.
So you ask one,
Uh-huh.
and you know that the direction of the leaf. Then after that you ask all of the siblings. Okay,
Okay, what is your
and
definition of sibling? Sorry. Is it the same parent, the same
the same
what is
parent,
it? The same
the
parent.
one with the
Okay.
same parent. Yeah.
Okay. Okay.
And we ask this in such a way that the answer is always the parent is always the parent.
Okay. Yep. 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 Yep.
So we never ask this one.
Yep. Yep. Yep.
And after we ask this one, we switch to the other leaf.
Yep.
And because we switch, know that if we ask this again, then
Yep. I
it's
think
just the leaf.
I think I mentioned that before, right? Basically, like you keep switching between the two. Yeah, yeah. Uh-huh. Uh-huh. So like you make sure you don't, like when you call a node, you make sure that the previous query is not that node as a parent, right? Yeah, okay. Uh-huh. Go ahead.
Yes.
Uh-huh.
Um, and let's say we switch to this one.
Uh-huh.
Ah, it doesn't work.
Uh-huh. Uh-huh.
Yeah, I was thinking like you can always maintain like two values, two of known.
Yeah, 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 yeah. But once once it merges to like one branch, right, it becomes a line. Um
No, the problem is what if it changes direction, but what happens if we are forced to ask this to signal that oh the
oh,
sign
okay.
changes.
Okay, okay, okay. Hmm.
Ah, okay, I don't know. Time to give up, I guess. Already a lot of hallucination.
Yeah. Yeah. Let's give up. Okay. Wait, that discussions online. Okay. Yep. Uh, everyone for watching, and thank you for some of the insights as well in the chat. Okay. Yeah. Once. Uh, shouldn't have opened that. Once the problem is available, I'll submit problem B. I don't know whether I want to code A or and C. Wait, what is A again? It's a some kind of construction, right? That's why I didn't code it because like the answer is not unique and it's hard to check. Uh, I lost the link. Oh, here we go. Oh, this thing, yeah. Hmm. Shouldn't be hard to code too. Yeah, so I'll probably code it for, uh, for submission. Okay, yeah.
Oh
Yeah.
no.
Yeah, please stop. There's no age. What are you talking about? No age. Okay, yeah. Good, good time to end, I guess. Okay, thank you everyone. See you again. Bye bye.
Everyone.